Happy learning! Today we're going to talk about functions. Before we get to functions, we need to talk about what a relation is. So, definition, a relation is defined by a set of ordered pairs or by a rule that determines how the ordered pairs are found. Okay, so for example, suppose I have the following set of ordered pairs. 1, 3, 1, 6, 2, 6, 3, 9, 3, 12, and 4, 12. So this set of ordered pairs expresses a relationship. So this set expresses a relation between the set. Well, what are the first entries in our ordered pairs? 1, 2, 3, and 4. So 1, 2, 3, and 4. And the set of second entries, which are 3, 6, 6 again, 9, 12, and 12. So just 3, 6, 9, and 12. Okay, so this set of ordered pairs describes a relation between this set of numbers and this set of numbers. The first entries, this is called the domain. And the second entries, that's called the range. Okay, and it is possible that one of the numbers appears both in the domain and the range. And typically we could visualize relations by having kind of arrows pointing. So here we'll have our domain, 1, 2, 3, and 4. And over here we'll have our range. And we could visualize the relation by having an arrow. So for instance, this ordered pair 1, 3, we're going to have an arrow from 1 to 3. We'll have an arrow from 1 to 6. 2 to 6. 3 to 9. 3 to 12, and 4 to 12. So this is a way to visualize the set of ordered pairs. We're going to be interested in a special type of relation, which is called a function. So a function is a relation between two sets such that to each element in our domain okay, you could think of the domain as the inputs. So to each element in the domain, there corresponds exactly one element in the range. And the range you could think of as the outputs. Okay, so does this represent a function? No, it does not. Why doesn't it? Well, the element 1 in our domain gets sent to two different parts of the range. So it's not a function. So this is not a function. Okay, let me give you an example of a function. So suppose this is our domain, and over here is our range. Again, I'll have just the numbers 1, 2, 3, and 4 be our domain. And let's say 7, 9, and 11 is our range. Notice these two sets are not the same size. That's okay. So maybe 1 gets sent to 7, 2 gets sent to 9, and 3 gets sent to 11. 4 also gets sent to 11. This is a function, right? Because each element in our domain gets sent to exactly one element in the range. It's okay that two things get sent to 11. We just care, is there one arrow out of 4? Is there one arrow out of 3? Is there one arrow out of 2? Is there one arrow out of 1? If the answer is yes for all those, then it's a function. Okay, so let's take a look at another example. And I encourage you to pause the video after I write out this example so you can try it on your own. But does the equation does y squared equal 2x express y as a function of x? Basically, what we're asking here is for each value of x, does it correspond to exactly one y value? If the answer is no, then this is not a function. All right, and so the answer is no, and let me show you why. All right, so if we take, for instance, x equals 8, we could find two y values that correspond to x equals 8, right? Because that would imply that y squared equals 16, 2 times 8. And there's two different values that have their square is 16, 4 and negative 4. Okay, so this value in our domain, 8, corresponds to two different values in the range, so we do not have a function. Okay, one way we could visualize relations is using something known as the Cartesian coordinate system. All right, so we're going to have these two axes. This is our x-axis, and this is our y-axis. And we could represent points, or ordered pairs, as points in space. Okay, so if we had the point, let's say we went 3 to the right and 1 down, this is the point 3, negative 1. Because we went 3 in the x direction, down 1 in the y direction. And just so we have some terminology, this region of the plane, this top right corner, this is called the first quadrant. And then we move counterclockwise. So this is the second quadrant, third quadrant, and then here is the fourth quadrant. So any point in the first quadrant has x positive, y is also positive. In the third quadrant, both of them are negative. And so we could use these planes to help visualize relations and functions. So let's take a look at an example. So let's sketch the graph of y equals x squared. And so one way we could do this is we could make a table of values and then plot the points and basically connect the dots. All right, so let's do that. So let's have a few values of x, and then we'll find their corresponding value of y. And let's just do maybe -3, -2, -1, 0, 1, 2, and 3. -3 squared is +9. If you type it into your calculator and you get a value of -9, that means you forgot your parentheses. All right, so make sure you put parentheses around your values when you're using a calculator. But -3 squared is certainly +9. -2 squared is 4. 1, 0, 1, 4, and 9. All right, so one way to sketch the graph of this function is just to plot these points and see what we get. All right, just kind of eyeballing it. Up here is the point -3, 9. And you can see we're going down, and then we're going to go back up. So the graph actually looks something like this. This shape is called a parabola. All right, and so how did we get it? We just plotted a few points and connected the dots. We'll eventually learn some more better techniques for graphing. Okay, so suppose I just drew some random curve in the xy plane, and you want to say, well, is this a function or is this not a function? And there's an easy way to check. It's called the vertical line test. So what does the vertical line test say? It says if no vertical line exists that intersects the graph at more than one point, then the graph is that of a function. All right, so if I just gave you this graph, we know it's the graph of a function because no vertical line crosses the graph twice. And if I gave you another graph, suppose I gave you a graph that looks something like this oval. This is not a function because it fails the vertical line test, right? This vertical line intersects the graph twice. Right? That's saying this x value corresponds to two different y values, which we know means not a function. All right, so let's take a look at evaluating functions at some specific values and how we do that. So if y is a function of x, and that function is given by 2x to the third minus 3x squared plus 1, I want us to do the following. So again, pause the video once I write out the problem. Try it on your own, but once you are happy with your solution, you could watch my solution. So I want you to find first f of 3. Then f of -1. And then finally, f of -x. All right, this notation, I know parentheses sometimes means multiplication, but when it's with a letter like F or G, it means we're doing a function. So this is a function of x. All right, so to get f of 3, this is saying wherever we see an x, we're going to replace it with 3. All right, so f of 3, wherever we see an x, replace it with 3. 2 times 3, to the third, minus 3 times 3 squared plus 1. This is just a number, so let's type it into a calculator, or just do it in our head. So 54 minus 27 plus 1 is 28. So this is saying when x equals 3, y is 28. All right, what about f of negative 1? Well, it's the same idea. Wherever we see an x, replace it with negative 1. So 2 times negative 1 to the third minus 3 times negative 1 squared plus 1. With these negatives, it's so important to remember your parentheses. Otherwise, you're going to get wrong answers. All right, so this is negative 2 minus 3 plus 1. That's negative 4. And now finally, f of negative x. Well, negative x is not a number, so what does this even mean? Well, basically what we're doing is saying, okay, what does our function do if we take the negative of some value? But the way we evaluate that is wherever we see an x, we're going to replace it with negative x. Our rules are exactly the same as before. So f of negative x, wherever we see an x, we replace it with negative x. 2, negative x to the third, minus 3, negative x squared plus 1. All right, and now let's clean this up a little bit. Negative x to the third. A negative raised to an odd power is still going to be negative. So this is negative 2x to the third. Minus 3, negative x squared. A negative squared is positive, but we still have this negative on the outside. So minus 3x squared plus 1. Okay, so f of negative x is actually just a new function that is related to our first function by some sort of reflection about an axis, which we'll talk about later. Okay, and so what I want to talk about now is the composition of functions. Actually, before we do that, let's talk about domain. So remember, the domain is the input. The domain is the input for our function. The range is the output. So how do you find the domain? So to find the domain, so basically, what values are we allowed to sub into our function? We're going to find all numbers except, all right, there's two rules we need to remember. The first rule, you cannot divide by 0. All right, so if we have some x's in a denominator, we just need to make sure whatever our denominator is not 0. Okay, so that's our first rule. You cannot divide by 0. Our second rule is you cannot take a square root or a fourth root or a sixth root or an eighth root, any even root of a negative number. There's no number when you multiply it by itself that gives you a negative. No real number. Okay, so the domain of the function, we find all numbers except values that result in an even root of a negative number. Okay, let's do an example. Find the domain, and we're going to do 3 of them. So first is the function y equals 4x squared. Next is the function y equals the square root of 4 minus x. And then finally, y is 1 plus 1 over x minus 2. All right, I really hope you pause the video and try this on your own. See if you could apply what we just wrote here to this problem. Okay. So for A, our function is y equals 4x squared. We have to check, is it possible to divide by 0? Is it possible to take the square root of a negative number? There's no denominators here, and there's no square roots. So there's nothing to worry about. The domain, so we write D for our domain, is all real numbers. Okay, so this bold R means all real numbers. All right, for B, our function is the square root of 4 minus x. We cannot take the square root of a negative number, so we're going to take the inside of our square root and say that it's not negative. All right, how do we do that mathematically? We would say 4 minus x, well, is not negative, greater than or equal to 0. That's what it means to be not negative. Now we need to get x by itself. This is easy, right? We just add x to both sides. And we have that 4 is greater than or equal to x. All right, so the domain, we could write in interval notation, negative infinity to 4 included. Or we could write it with the number line. Four is the biggest, and any value smaller than 4 is allowed. Okay, and now finally, y equals 1 plus 1 over x minus 2. This 1 is just hanging out. It's not causing us any problems. This is where the problems could happen, right? Because we have a denominator. We have to avoid values that result in the denominator of 0. So let's take our denominator and say it's not equal to 0. So x minus 2 does not equal 0. All right, now we have to figure out which values of x satisfy this inequality. Well, adding 2 to both sides says x does not equal 2. All right, let's, just for fun, what does this look like on the number line? Well, we would go to 2, we'd put an open circle, and we would shade everywhere else. Okay. Yeah, so what are the takeaways? If you have a square root, set that greater than or equal to 0 and solve. If you have a denominator, set it not equal to 0 and solve for x. Okay, now let's talk about the composition of functions. So the composition of functions, basically, you could think of You do this in your everyday life if you ever like change units. Okay, so you have so many US dollars, you want to know how much money you have in euros, you'd have to change units. If you're in the United States and you're driving in miles per hour and then you go to Canada, you have to figure out what is the corresponding value in kilometers per hour. But mathematically, the way we do this is something called the composition of functions. So let f and g be functions. Then the composition functions g of, let's write that down here, g of f, which we write G circle F, Goff, and F of G, which we denote fog. Are defined as G of F of x is equal to g of f of x. We take our g function, wherever we see an x, we replace it with the entire f function. For f of g of x, we take our f function. Wherever we see an x, we replace it with the entire g function. These are going to result in new functions. Okay, so let's take a look at a few examples. All right, so if f of x is 2x to the third plus 1, and g of x equals x squared, we want to find g of f of x and f of g of x. Okay, I encourage you to try this on your own. Right? It's really easy to just watch me do math problems. But you're not going to learn unless you actually try them and struggle with the problems, and you'll see like common mistakes that you make, and then you'll avoid them. All right, so let's start with A. So g of f, right, is g of f of x. We take our g function. Wherever we see an x, we replace it with the entire f function. All right, so we have one x here. So it's 2x to the third plus 1 squared. I'm going to multiply this out. So you cannot distribute the squared. It's not how algebra works. What is something squared? It's that number times itself. So this is equal to 2x to the third plus 1 times itself. How do we do this multiplication? You distribute, or you do FOIL. So first, 4x to the sixth. Outer is 2x to the third. Inner is also 2x to the third. So that's 2 plus 2, 4x to the third. And last is just 1 times 1, which is 1. All right, so g of f of x is this function. Let's now find f of g of x. So we take our f function, wherever we see an x, we're going to replace it with the entire g function. All right, and we get 2x squared to the third plus 1. X squared to the third, remember we multiply the exponents. So this is equal to 2x to the sixth plus 1. So g of f and f of g are different functions, so the order does matter. So you got to keep track of what order you're going to do it. G of f, we take g and sub in f for wherever we see x. And for f of g, we take our f function. Wherever we see an x, we replace it with g. OK, well, I hope you liked today's video, and I'll see you in the next one. Bye-bye.